From the studios at WMFE in Orlando, Florida, this is the Space Exploration Podcast, asking the question, are we there yet? Thanks for listening. I'm Brendan Byrne. All right, for the next half hour, we're going to be talking to a former astronaut about building an orbiting base camp at Mars. I have the coolest job, right? Well, Tony Antonelli spent 24 days in space as a shuttle pilot, working on building the International Space Station. And now he's the chief technologist for Lockheed Martin's Civil Exploration Division, and he's working on building the next space station, this one bound for Mars. Lockheed formally announced the plan earlier this month, with hopes NASA will consider it as they finalize their plans to send humans to Mars. And as Tony explains, the idea uses technology we already have or are close to developing.
First, it's just a vision to offer up to NASA. So it's not so much Lockheed's plan. NASA has been for a while asking, and most recently, David Newman, the deputy administrator at NASA, was on stage at the Humans to Mars Summit, and she said, look, this NASA's journey to Mars is inclusive. We need everyone's help. We need, of course, all the NASA centers. We need industry and, academia. And we need everybody looking at, helping us solve this problem. And so this is just, Lockheed's vision that we're offering up to NASA for consideration, and only one aspect, really, of the whole integrated NASA's journey to Mars for the American people. So,
because NASA's journey to Mars, they've got some test flights lined up for Orion, which you folks are working on. They've got a crewed flight coming up, but then after that, it's kind of there really are no set plans to kind of finish off that mission. How does your vision, as you say, kind of fit into that? We'll call it that last few miles of the journey to Mars.
Yeah, so I think you characterized it pretty well. That one piece that they have laid out in the cislunar space arena, various orbits around the moon. They've laid out some flight test objectives that they want to accomplish to be able to demonstrate the capability of a spacecraft to be able to support humans on, that is far away from Earth as a trip to Mars would be, as well as develop the confidence in the actual architecture. And so what we put together was an architecture that gets built up in cislunar space, the elements of, gaining the confidence operating, days away from Earth, as opposed to, 45 minutes away from Earth, like the International Space Station is. And then with the idea that you would build up the architecture in cislunar space, the majority of it there, at the same time you'd be developing the confidence in it, and then you would push off on the journey to Mars.
So you're going to build this thing closer to Earth than just sending all of the pieces out to Mars, right? It would be built in pieces, and when you say cislunar, how far away is that?
So we're looking at a few different, we being the NASA's looking at a few different orbits around the moon. They have, each one you choose has advantages and disadvantages, so you have to weigh them against each other based on what you're specifically trying to accomplish. And so those are still being looked at, but they're the orbit for the Exploration Mission 1, Orion's next flight that's scheduled for 2018. It'll go about 40,000 miles past the moon, so it'll end up being a distance record-setting mission for human-rated spacecraft.
Gotcha. So, paint me a picture. What are you calling this thing? Is this a space station? Is this a base camp? Is this a spacecraft? What would you call it?
Yeah, so internally we're calling it Mars Base Camp, and we got that as so what we're talking about is a Mars orbiting architecture that includes, of course, human-rated pressurized volume. In addition, it includes a scientific laboratory. So if we're going to send humans to Mars orbit, we think we can do significant science with low latency telerobotics on the surface. We can collect surface samples launched off the surface and analyzed and curated in the laboratory before we return them back to Earth, as well as leveraging Orion's capabilities to do excursions to the Martian moons. And we're calling it Mars Base Camp with the idea that we'll have this global perspective from an orbiting Mars laboratory, and then we will step off from there to, I guess, kind of do the opposite of the summit, but from this Mars Base Camp, get down eventually to humans on the surface of Mars.
You mentioned lowering the latency. Can you kind of explain what the challenges are with the rovers now and what having this base camp would do with that control latency?
Yeah, so I can start the explanation, but we really need the help of the science community. So the rovers today are operated on the surface of Mars with one-way speed of light communication restriction on the order of 20 minutes. And that's only part of the opportunities, I guess, for how to operate them differently. But the way the scientific community collects that data and decides what to do next is more on a 24-hour cycle. They send a set of commands up to the orbiter closer to once a day. They can surge a little bit more than that, but not much. And so the low latency will allow you, but it's a combination of things. You also have to do rovers that are not really kind of national assets so that you can take them right up to the edge of the cliffs to look at the scientifically interesting places. So you have to have more of a fleet of small rovers that you can maneuver around and take full advantage of. And the scientists need to be there in person doing the science is a key piece of that. The scientific decisions, what is scientifically interesting, has to be there to take advantage of the flexibility of the human mind. And so if you leave all the scientists at Earth and just send, robot drivers there to take advantage of the low latency, you're really not going to reap the benefits. In addition, our skunkworks guys have been designing some UAVs that are designed to be flown in the Martian atmosphere, and now from an orbiting outpost, low latency, you can actually, actively control and fly UAVs.
Remember, those are unmanned aerial vehicles?
Yes.
So tell me about the Mars Base Camp. What is it actually going to look like? What's the size of this thing?
So it's more than describing, what it looks like, which you can see on the Lockheed Martin website, is kind of what goes into it, right? And so it's leveraging existing technologies and technologies that are, currently under development. Think of it as kind of Orion spacecraft as the command and control, as the backbone from an avionics standpoint, if you will, kind of running this, overall larger spacecraft. It has a laboratory, and it has a habitation module. It has a crew quarters, which is essentially both Orion and their crew quarters are covered up in the picture if you go online and see it by the tanks, the propellant tanks. And so most of the interesting stuff from a Lockheed Martin standpoint is, Orion's role in this architecture. And then when we put it together in a picture, it's mostly covered up. And that's because we want to protect the crew as much as we can from radiation. And the way you do that is you put them as deep inside, if you will, and as many other things shielding them from the radiation as you can.
Like in comparison to the International Space Station, would this be something bigger, smaller?
So quite a bit smaller than the International Space Station. and for a lot of different reasons. One is, this is something we think we can put together in cislunar space and launch out to Mars in the 2028 timeframe. And then also how much harder it is to get a kilogram, if you will, all the way to Mars and back than it is to low Earth orbit. So both of those things kind of drive you to a optimized size.
And how long can these astronauts stay on the Mars base camp?
Yeah, so this mission is laid out currently 2.5 to 3 years. So there's a part of that is the 6 to 9 month journey out there, and then they're in Mars orbit and or doing excursions to the Martian moons for just under a year, or about a year.
So still need to figure out how to get humans in space for that long, right?
Yeah, and that's being worked on at a bunch of different levels. I think the one that's gotten the most press was Scott and Misha's 1-year mission to the International Space Station. So that's part of it. There's also several Earth-bound studies where they're trying to solve a lot of the other issues in addition to the microgravity part that you get on the International Space Station. A lot of the other issues of humans living in deep space for that long duration.
You mentioned you're using either technology that we currently have or technology that's in development. You mentioned the Orion capsule. What are some other things that you'll be using for this architecture to build this Mars base camp?
Yeah, so the large elements are launched on NASA's Space Launch System. So it's SLS and Orion that are both getting close to finishing up their development. Two other key pieces are Deep Space Habitation Module, which is, I'll say, in the transitioning from the first phase to the second phase of their announcement under a NASA broad area announcement called Next Step. That's kind of an umbrella program, and one piece of that is deep space habitation. And then another piece is advanced solar electric propulsion, and that's currently being run as a NASA program for the ARM mission, the asteroid retrieval mission. And this Mars Base Camp architecture takes advantage of that scaled-up solar electric propulsion. So solar electric propulsion has been flying on satellites for over a decade, so it's not something brand new, but this ARM mission is looking at scaling it up in size. And we would take advantage of that capability to forward deploy assets because it's very efficient in-space propulsion. It takes a little longer to get stuff to Mars, but you can take a lot more mass if you're willing to sacrifice some of the time. And we would take laboratories, excursion vehicles, and the like. And a couple of things that provides you is that when the solar arrays are not producing power to run the thrusters, then you end up with that electrical power to power all the laboratory equipment that you would forward deploy in a lab. And then having the scientists and the laboratory right there in Mars orbit allows you, again, to take advantage of the stuff you learn. If you collected samples in Mars orbit but didn't study them until you brought them all the way back to Earth, and then you learned something that made you want to collect a different sample or more of a particular sample, you would have missed the opportunity. So that's why we see it as part of the plan to put not only the scientists there, but also the laboratory equipment to take advantage of having the folks there.
Aside from getting funding and getting accepted by NASA, what are some hurdles that that a project of this scope and magnitude might face?
Yeah, so it's more about what this offers to help you through some of the hurdles. So one of the big hurdles, I believe, with getting humans to Mars is making it tangible, making it real to folks, that to say, look, we could actually, with the technology we have today, we could we need to do some systems engineering, but we can set our mind to setting on this journey to Mars and making it real for folks, as opposed to something that's just too far out in the future for you to get interested and excited about. So Orion will fly Exploration Mission 2, which will be the first crewed flight of Orion in 2021, and it will set a distance record for humans away from planet Earth. And so that's in 2021, and this architecture kind of has, something important and relevant to everyone kind of happening almost annually from there to 2028. And so the thing that we think, one of the hurdles is, making it real to people. And so part of bringing it in and making it real is not letting the calendar get pushed out too far.
And I mean, what kind of a crucial milestone is that EM2 in 2021 in drumming up public support? Like, once that happens, do you think we're going to see this flood of public support for deep space exploration?
I think the flood of public support already exists. So Lockheed Martin and NASA flew Exploration Flight Test 1 in December of 14, and that was Orion's first test flight. And there was, a tremendous amount of support for that first test flight. And so I think it's just a regular cadence that needs to be developed. And so we flew Exploration Flight Test 1 in December of 14. Like I said, we're flying the Exploration Mission 1 in 18, which will be a uncrewed flight, and again a record-setting flight. And then 2021 will be EM2, and then it'll be shortly after that getting on an annual cadence as we continue to set duration records in deep space, outside of low Earth orbit, and we build up this architecture and we fly in parallel to this. Our planetary exploration and robotics precursor missions that will prepare for the human landing site are going on at the same time. So there's a Mars 2020 rover that NASA has on the books that will actually cache surface samples on Mars. It doesn't have the ability to launch them into Mars orbit yet, but that will come during this time frame. Addition to that, NASA just announced their next Mars orbiter, which will be about the 2022 time frame, and it'll have hopefully this advanced solar electric propulsion. It'll have high bandwidth communications so that we can start getting the data that we collect at Mars today with Lockheed Martin's Odyssey, Mars Reconnaissance Orbiter, and MAVEN spacecraft. Those instruments there collect more data than we're able to get back to Earth because of the communication architecture that's in place today, but will continue to be advanced. And I think that Mars 2022, or the next Mars orbiter in the 2022 timeframe, will further advance that. So there are these kind of parallel efforts to not generate this swell or flood of public support, but just to keep it, because that's already there. We just need to keep it invigorated.
Yeah, I was out in the crowds for EFT1, and it's like something I had never seen before. It's really cool to see all those people really coming around this, uncrewed test flight, basically, and they were super excited about it. NASA's faced a little bit of criticism with SLS not having a launch schedule for that, not having a payload set aside for that. Does having a plan like a Mars base camp like this, where it is put together in pieces in cislunar orbit, like you said, Does that kind of alleviate some of the pressure and make it a little bit easier to get that SLS developed?
Yeah, and I think there are various ones of these, the ideas out there, and instead of sitting back and criticizing NASA, we're taking their request for help seriously and rolling up our sleeves and trying to work hard to find a plan that leverages the capability and the investment in SLS as well as in Orion. We want to leverage the nation's investment in Orion and find an architecture that really takes advantage of Orion's capability. So it has redundant, multi-string, radiation-hardened avionics and, completely human-rated deep space spacecraft. And so we want to find as many uses for that capability so that we don't have to start new with each element of the architecture. In addition, NASA has their flight test objectives that they want to accomplish in cislunar space to develop the confidence to send humans farther and farther away from Earth. And so we're really, taking their request for help serious and trying to move us all forward on the journey to Mars.
When can you expect to get the go-ahead or the green light from NASA on this?
So it's more of individual elements, right? So SLS is well on its way. I would say, to answer your question, I would say they have the green light. Orion, we have finished the welding of the EM-1 spacecraft in Michoud, and we shipped it out to Florida earlier this year. We just recently, within the last few weeks or a month, completed the proof pressure test. So we took that EM-1 pressure vessel, the spacecraft that's going to the moon, and did a pressure test to make sure that it passed all of the requirements that we've laid out for it. And now we're continuing to assemble that spacecraft there at the Kennedy Space Center. So clearly the green light has already been set for all of those elements. The advanced solar electric propulsion is in the study phases now as part of the ARM mission. I thought that schedule was late this year. And then the habitation module under the Next Step umbrella we're in parallel. We're finishing up phase 1 of the study, and proposals are due to NASA for phase 2 of that study the middle of this June, so just in a few weeks. And so we already have the green light for, significant pieces of this, and I think we just need to stay on that cadence.
Tony, thinking back 10 or 20 years, did you ever think you'd be planning a Mars orbiting architecture?
Yeah, when you say 10 or 20 years, I instantly leap to me being a child, but then when I actually do the math, I go, oh, wait, no, I was... Unfortunately for me, I wasn't a child 10 or 20 years ago. So as a child, I absolutely did. I, thought that when I was in the business, I don't know how much Allison told you about my background. I thought when I was in this business, we would be well on our way. And when I was really young, I thought, man, I wish I was older because I wanted to be the first person to walk on Mars. And, that's already going to happen before I become an adult and have a shot at it. And so I think 10 or 20 years ago, we were just as far from pressing on with the journey to Mars, and more than what I thought 10 or 20 years ago, it's what I will think 10 years from now. And I've heard a lot of folks use the phrase, the Mars generation, and talking about school children and grandchildren. And human exploration of Mars is my dream, and I want to see it happen in my career. And I don't want to tell my grandchildren what their dreams should be. I would rather, work hard to accomplish mine And then I still think there's plenty to do in space exploration, so I'm not worried about getting too far ahead and taking all of the great opportunities from them. I think if we can do human exploration of Mars in our careers, then they will just take that and they will dream bigger dreams, and they will accomplish bigger things because of the work we are able to accomplish.
And for our listeners, we should mention you have been to space, right?
Yeah, I was lucky enough to get to fly as the pilot on 2 space shuttle missions, and both of those trips were up to the International Space Station for essentially assembly work.
And you're doing sort of similar work down here with a kind of Mars architecture, right?
Yeah, so that was more of the operations, right? The space shuttle was already designed, and it was just my role in that was just to get in and learn how to fly it and operate it. And this is more of the put the design together to make this happen. But I am really excited for the folks that would get to climb into Orion, even on the early exploration missions where they get to go out past the moon, see the moon up close, and see the Earth from 250,000 miles away. You've probably talked to folks before that have flown on the space shuttle or space station. They say, looking back at Earth from just a couple hundred miles changes your perspective. I know you know this, and all your listeners know this, but you probably don't spend a lot of time thinking about it, that, you live on a planet, and we all live on just one planet. And I think if you start to get farther away from Earth and look back at Earth, you kind of think about all of us together a little differently.
And can you imagine what that view is going to look like from Mars Base Camp?
Yeah, I've tried. It's hard. So luckily the Apollo guys, Bill Anders took the Earthrise photo on Apollo 8 that gives us all that perspective of what Earth looks like from the moon. And Exploration Mission 2 on Orion, astronauts are going to have an opportunity to look back at Earth, out the window and see it for themselves, which is even more powerful than a picture. But when you think about looking back at Earth from Mars, it's going to look, very similar to how Mars looks in the night sky. And when I see Mars in the night sky, it's really hard to make the transition from there to like the images we get from the Mars Reconnaissance Orbiter or the Curiosity rover, right? When you get those pictures, you think of it as a planet, but when you look at Mars in the night sky, you think of it as just a twinkle of light. So it's hard for me to mentally connect those, but that's the connection you're going to have when you're in Mars Base Camp orbiting Mars. You're going to see Earth in the night sky as just a twinkle of light, and imagine that that's your home planet. And it'll be changing for all of us, I think.
Tony Antonelli, thank you so much for taking the time to speak with me.
Yeah, thank you. I enjoyed it.
Well, that's going to do it for this episode. Support for Are We There Yet comes from the listeners of WMFE. Follow the show online. We're at Twitter, at AWTYMars, or reach out to me in the Twitterverse. I'm at SpaceBrendan. Leave us a review on iTunes. That's how new people learn about this podcast. Are We There Yet is a production of WMFE. Our theme music was composed by Kevin McLeod. You can find more space news online at WMFE.org/space. Once again, I'm Brendan Byrne. Thanks for listening.